this section should be really easy because it's the same story as the previous one, except that the salt is of the opposite kind. We have, say, NH4Cl, which is supposed to be made from NH4OH, a weak base, and HCl, a strong acid. And we have C molar. First of all, when we say C molar for NH4Cl, there is no salt for sure. It has fully broken into NH4 plus aqueous C molar and Cl minus aqueous. By the way, when we say C molar of NH4Cl, we were talking about aqueous. We have dissolved. So it's a way of saying that we have a 3 molar or 0.4 molar NH4Cl, but NH4Cl doesn't exist as a molecule. So we have NH4 plus and Cl minus, both of them C molar, of which only one is going to hydrolyze. So what do we have? A cationic hydrolysis or an anionic hydrolysis? So answer is yes, this time it's a cationic hydrolysis. Only NH4 is going to hydrolyze. It is going to react with water. It is going to react with the OH minus from water. It is the Cl minus is not going to react with H plus. Why? Because HCl molecule cannot be formed because that molecule is going to break up fully. So this reaction doesn't happen. So this is not going to happen. What is going to happen is NH4 plus is going to react with OH minus, which was coming from water, and it can form a molecule NH4OH, which can in water hold itself as a molecule. So it's a whole molecule which is dissolved in water. So this can exist. So this is because it's a weak base, it doesn't dissociate fully. So this can exist. So this hydrolysis is happening. So when we combine this reaction with water giving H plus and OH minus, then we ultimately come up with a reaction which is your NH4 plus aqueous is hydrolyzing or reacting with water. It's a cationic hydrolysis which is happening. So you have NH4 plus, which was totally your C molar because they are C molar salt. So C molar of that. C was the molarity of that. So that is hydrolyzing with water, and it is giving you what? It is giving NH4OH plus. This water was HOH, right? So NH4 plus in a way is breaking down water and it is combining with OH minus, forming NH4 OH minus in a way, I'm telling you. Okay, the real story is what was told earlier. What is the real story? The real story is this NH4 actually reacts with the OH minus which has been coming from water and drives the water equilibrium further towards the right because the OH minus is getting consumed, right? So in a combined way, we can say that NH4OH is actually reacting with water and releasing H plus. So that's a way of saying, so that is what is called as hydrolysis. So NH4 is attacking water, breaking up water, reacting with it and combining with the OH to give you NH4OH, and H plus is getting released. So what we have over here is H plus. H plus is getting released. So that's your hydrolysis equation. This is your hydrolysis which is happening. That's your hydrolysis. So this hydrolysis will be having a hydrolysis constant, which will be KH, which will be called KH again. Hydrolysis constant. So what is that hydrolysis constant? That hydrolysis constant is NH4OH multiplied with H plus. Guys, you should have done the previous video, so because I'm just going through this. This is a kind of revision of the previous video. Divided by NH4 plus, and our job is to get that hydrolysis constant because nobody is going to give the hydrolysis constant. What would they have given in the question? So actually they would have given just the Kw value, or they would assume that you know the Kw value and the Kb value, right? They would have given only those two. And how do you use that? So if they have given the Kb value, we'll write the associated reaction. What is the associated reaction for the Kb? Kb of what is given to you, by the way? Kb of the base, right? Kb. So ionization constant of the base. So the base is this. So they have been talking about a salt, but they give you the ionization constant of a base, right? Because they know that somehow the base is there in the solution, right? Right. So what's the Kb value? What's the Kb of a base? So we write the associated reaction. We'll write NH4OH gives NH4 plus and OH minus. I'm just not writing the aqueous all over. That's your associated reaction of the Kb. So when they gave you Kb, when they are giving you Kb, they are in fact giving you the multiplication and division of the concentration of these ions. NH4 plus OH minus and NH4OH. So they have given you this. And for sure all of these are in the solution. As I always draw, so I'll draw again what all are there in the solution. You have H plus, you have OH minus, you have H2O, you got NH4 plus from the salt, you got Cl minus from the salt, then NH4 hydrolyzed in the cationic hydrolysis and it formed NH4OH. So right now I'm talking about the equilibrium which NH4OH, NH4 plus and OH minus is going to hold. Yes, these three are in the solution, so they will be holding an equilibrium which will be governed by the Kb value. Another kind of equilibrium which will be going on in water is H plus and OH minus with water itself, and it will hold the Kw value. What is that? And then this is the equilibrium which is there, the hydrolysis. So the hydrolysis constant Kh can be figured out, and we'll do the same thing. We have H plus over here. We have to somehow get the Kw in the picture. So to get the Kw in the picture, we'll just multiply with OH minus on top and OH minus on bottom. So can you tell me what would be the Kh value in terms of Kw and Kb? From here what you see is this is your Kw value, and this part is fortunately your 1 by Kb value. So what has happened is your Kh has come out to be Kw by Kb. Again, something what you will eventually remember. You can memorize for now. You have to remember there is no exceptions over there. There is nothing like you are considering less hydrolysis or more hydrolysis, nothing like that. Whether the hydrolysis is minuscule or is immense, your Kh is equal to Kw by Kb. Now once you have figured out the hydrolysis constant, then figuring out how much is the amount of H plus generated due to the hydrolysis is not a big deal, because you had the initial amount of this. Initial amount of this will be ditto same as the amount of salt, which is say C molar. You have figured out the hydrolysis constant, so you know the K value of this reaction. So if you know the K value of the reaction, then you can figure out the degree of hydrolysis for the reaction. Once you have got the degree of hydrolysis, then the H value will be nothing but C times the degree of hydrolysis, right? So same steps as earlier. So I'll just in a fresh page I'll write it. We have NH4 plus reacting with water to give you NH4OH and H plus. So NH4 is actually breaking up the water, and it says that okay, H plus you don't combine with OH minus, I'm going to combine with OH minus, and I'll release you from water. So this NH4 actually combines with OH minus because it's a stable molecule. It wants to remain as a molecule. So NH4 readily combines with OH minus and H plus is released. So as in my previous bluff question over here also, the question is, why is this process not a very likely process? Why it is not a very, it's a reaction which is all forward. Why the hydrolysis, degree of hydrolysis is going to be very low is my question. Again, I am putting it that NH4 wants to readily combine with OH minus to give you NH4OH which wants to remain as a molecule. Actually, if I got a NH4OH molecule, it will remain as an NH4OH molecule. Hardly a percent of it is going to break back into NH4 plus and OH minus. Why? Because it's a very weak base. So it will remain as a molecule, remain like this. So if that's the story, then why is the reaction not forward badly? Anyways, coming back to the problem at hand, what we know is that initial amount is C. There's nothing of this, nothing of this. All is aqueous, by the way. Okay, aqueous. Don't even have to write aqueous because water is with water. Won't harm if I write aqueous. Looks funny. Aqueous. So C, nothing, nothing. After a while, the degree of hydrolysis is H. So CH amount of it has combined or has succeeded in breaking the water and forming NH4OH. So I should rather say has combined with the OH minus and formed NH4OH. And this is CH and this is CH. So the pH of the solution is, or the concentration of H plus is this CH amount, and the contribution from water itself, of the initial contribution from water itself is being ignored for now. The initial contribution from water itself was 10 power minus 7. If CH is anywhere near 10 power minus 7, 10 power minus 6 and all, we will add up that also. But if it is coming at 10 power minus 4, 10 power minus say 5 also, we are not going to add up a 10 power minus 7 to it. So most of the cases, the CH value comes more than 10 power minus 5, and hence we are just ignoring the contribution from water. And this H plus is totally being considered due to the hydrolysis. So what we have is our KH is equal to CH square. So C into H, C square H square upon C 1 minus H, where we assume that H is very, very less than 1, and we consume 1 minus H as 1 itself. So what we get is CH square. So that means your degree of hydrolysis is equal to under root of KH by C. So that's your degree of hydrolysis. So what is the amount of H plus? The amount of H plus, or the concentration of H plus, is equal to C times H, which is under root of C into the hydrolysis constant. Now hydrolysis constant we have already figured out. What is that? Kw by Kb. So you see, again a funny thing, you have concentration of H plus being talked about and a Kb of some base is there in the formula. Anyways, that's the formula. So you may remember this formula. If I take the negative log all over, what do I get? I get the pH value. I'll consider my Kw as 10 power minus 14. So I'll get 7 minus, it's an acidic solution now because it was strong acid with weak base, right? So the pH will be less than 7. 7 minus half pKb minus half log C. So what do you see? You see the answer in the same format as earlier. The previous answer was POH is equal to 7 minus half log pKa minus half log C. So I'm asking you to remember in this format because you don't have to remember unique formulae. It will be the same, 7 minus half pKa minus half log C in case of POH, and in case of pH 7 minus half log pKb minus half log C. So that's it. Let's do a question on this in the quiz which follows and get some confidence with respect to hydrolysis of a salt which is from a strong acid and a weak base. Thank you.